Hello and welcome to our 27th episode in our Pharmacy Calculations Practice series. And we have two questions for you today that can be solved using allegation. So hopefully these will be good examples of how to use this method. And you can use allegation anytime you are being told to compound something where the percentage concentration is somewhere in between two other concentrations that you have on hand. So if you're given two numbers that you have that you can use to compound something, but you need a number somewhere in the middle, you're going to use allegation. So in this example, they're telling us that the pharmacy receives an order for 1,000 milliliters of D20W, or 20% dextrose solution. What we have on hand is 70% and 10%. So how much of each of those are you going to need to get to 1,000 milliliters of 20%? So we're going to set up our tic-tac-toe diagram. That's what I call our method here for doing allegation. You draw what looks like a tic-tac-toe diagram. You take the higher concentration you have on hand, you put it in the upper left. You take the lower concentration you have on hand, and you put it in the lower left. And you put your target concentration right in the middle. And now that you have that set up, you take that higher concentration, you subtract the desired concentration, and you write that number in the bottom right. And then you take the desired concentration, subtract the lower concentration, and you put that number in the upper right. And then what these numbers tell us is the parts of each solution on the other end of the diagram. So we're going to have 10 parts of 70% solution for every 50 parts of 10% solution. And it's also important to look at how many total parts you have. And this will make more sense here in a moment. So we have 60 parts. 10 of those parts is going to be 70% solution. 50 of those parts is 10% solution. Now, hopefully this will make sense when we go ahead and solve for how much volume of each of those solutions we're going to need. Our total volume that we need to compound is 1,000 milliliters. We can figure out how much of that is 70% by multiplying it by our fraction of 70%, which is going to be 10 parts out of 60 parts. Okay, so 1,000 milliliters times 10 divided by 60 is going to be 167, we'll round that up, milliliters of 70% solution. Okay, but we also need to know how much of the 10% we need. And we can either do the same exact thing, or we could just take 1,000 milliliters subtracted by the 167, because we know the remainder is going to be 10%. But just to check our work, we'll take 1,000 milliliters and multiply it by the fraction of 10%, which is going to be 50 parts out of the 60 parts. And that number is 1,000 times 50 divided by 60 is 833 milliliters of 10%. And if we want to double check our work, we can just add these two together, and they should total 1,000 milliliters. So hopefully our multiple choice answers will give us the option to select 167 milliliters of 70% and 833 milliliters of 10%. Now we'll move on to the next question, and hopefully this will be a little easier now that we've seen how to do this once. We have an order to compound 500 milliliters of a 25% amino acid solution. We have a 75% amino acid solution in stock. How much sterile water is needed for this order? So we threw a little curveball in there. So they're not asking how much of each, they're asking specifically, how much sterile water are you going to use to compound 500 milliliters of a 25% solution when you've got a 75% solution in stock? So the real key here is you need to understand that sterile water is essentially going to be equal to 0%. Okay, it's just water. It doesn't have any other ingredient in it. It doesn't have any amino acids in it. So it's 0% amino acid solution. So we can set up our tic-tac-toe diagram again. We put our higher concentration in stock in the upper left, our lower concentration in the bottom left, which is 0%, that's the sterile water, and our desired concentration in the middle. And then we do the same thing we did on the last example, 75 minus 25, so I believe that is 50, and then 25 minus 0, which is going to be 25. So this means we're going to have 25 parts of 75% solution for every 50 parts of 0% solution or sterile water, and the total here is 75 parts. Now, if we needed to compound 500 milliliters and we need to know how much of that is the sterile water, so that's this part right here, we take 500 times 50 over 75. So that's the fraction of sterile water. And that answer will be 500 times 50 divided by 75, 333 milliliters will be your answer. Hopefully that made sense. If it didn't, or if you need to see some more examples, feel free to check us out on our Facebook page here. You can also email us your questions at info@pharmacytechscholar.com.